Hello, I'm Mr. Kelvin from Educare Institute, and I'm in front of you today to discuss physics form 3, the topic known as current electricity, and our subtopic today we will look about equivalent resistance. When we say equivalent resistance, means the summation or the sum of all resistance when they are either connected in series or connected in parallel, or when they are in series configuration or in parallel configuration. So when the resistance are connected in series or when they are in series configuration, their resistance value can be calculated in such a way that the total resistance will be equal to sum of R1 means resistor 1 plus resistor 2 plus resistor 3 up to resistor N. Means N is a number of the resistance you have. So if you have a 5 resistors, means you will end R equal to 5. So, but when you are given identical resistors, you can calculate the resistance total or total resistance or equivalent resistance by taking the number of identical resistor, which is represented by the letter N, then you will times the value of the resistance you are given. So that is how you can calculate resistance when they are connected in series. But when they're in parallel configuration, you can calculate the total resistance by taking 1 over resistance total is equal to 1 over resistance 1 plus 1 over resistance 2 plus 1 over resistance 3 plus dash dash plus 1 over resistance N. But when you have identical resistance, you have to use the formula such that equivalent resistance is equal to the value of that identical resistance, then you will divide by the total number of those identical resistance. So let's now look on the examples. Example 1, consider the figure below. The figure is such as it looks on the diagram. So given that the battery has a voltage of 9 volt and R1 is equal to 4 ohm, R2 is equal to 5 ohm, and R3 R3 is equal to 6 ohm. Then you are required to find the following values. The first one, you are required to find the total resistance, but in part B, you are required to find the current flowing in the circuit. But part C, you are required to find the potential at point A. So, as you look on the diagram, you have given the battery, which is the source of voltage to operate the circuit. You have a resistor 1, resistor 2, and resistor 3. And you have been given the value of the resistors and the value of the voltage. So, the first part, you are required to find the value of equivalent resistance. How you can calculate the equivalent resistance? As you look, our resistances are in series connection. So, to calculate the value of total resistance will be equal to R1 plus R2 plus R3. So, resistance total will be equal to R1, we are given, is equal to 4 ohm, will plus R2 is equal to 5 ohm, you will plus, and R3 is 6 ohm. So if you plus, you will get R total is equal to 15. That is the value of the equivalent resistance. Because our resistance are in series, so you can calculate by using the formula of the resistance in the series. At part B, we are required to find the current flowing through the circuit. To find the current flowing through the circuit, we can say current is equal to voltage divided by the total resistance. And the voltage you are given 9 volt, then we'll divide by total resistance is 15 ohm. So current will be equal to, if you divide, you will get 0.6 ampere. So you will say current flowing in the circuit is equal to 0.6 ampere. That is how you can calculate the current flowing through the circuit. But part C, we have required to find the potential difference at point A. So what is the potential difference at point A? To find the potential difference at point A, let's first find the potential difference at all points. Then we can able to find the potential difference at point A, because our resistances are connected in series. So we'll find the potential drop in each resistor. So to find the potential drop in each resistor, we can use the formula from Ohm's law. So in resistor 1, the potential drop will be equal to current times the resistor 1 will be equal to current, we get 0.6 ampere times the value of R1 was 4 ohm, so V at R1 will be equal to 2.4 volt. So what will be V at R2? Potential drop at resistor 2 will be given by V of R2 will be equal to I times R2, which will be equal to I is equal to 0.6 ampere times the value of the resistance is 5 ohm. 5 ohm. If you times the V, or potential drop at resistor 2 will be equal to 3.0 volt. So now let's find the potential drop at at resistor 3. At resistor 3 will be VR3 is equal to I times R3, which is equal to 0.6 ampere times resistor 3 is equal to 6 ohm. So if you take the multiplication, you will get potential drop of resistor 3 is equal to 3.6 ohm. That is the resistor at all points, or at all resistors. So to find the potential drop at point A, we know that the potential difference we start to read at 0 volt, or at the negative sign. So if you look in our diagram and you trace back, you will see that to find the potential at point A, we will get equal to potential at resistor 3, then we plus potential at resistor 2. If you plus the potential from resistor 3 and resistor 2, you'll get the potential drop at point A is given by, you'll take 3.6 ohm, you plus with 3.0, sorry, here is volt. So if you take 3.6 volt and you plus 3.0 volt, you will get the value equal to 6.6 volt. So we'll say potential at point A is 6.6 volt. That is how you can calculate the potential drop at point A. So now let's look on the another example. Example number 2. Example number 2. In the circuit below, the battery has a voltage of 9 volt. Resistor 1 is equal to 4 ohm resistor 2 is equal to 5 ohm and resistor 3 is equal to 6 ohm. Then let's show the diagram, how the figure looks or how the circuit looks. So from the given circuit, find A equivalent resistance and current flowing. And the total current flowing. Also in B, you are required to find current in each resistor. And the last, you are required to find the sum of current, flowing through the circuit. So that is our question. You are required to find first is total resistance and total current